Hello everyone. So we completed the three topics of non-preemption methods in CPU scheduling algorithms. Now let's come to the preemption methods, which are very important, that they will be asked in every examination. So in preemption methods there are four methods. So the first method is SRTF, shortest remaining time first. So which is the most similar to the SJF, the shortest job first, that we saw in the non-preemption method. Okay, so in shortest remaining time first, so what is the criteria that we are doing? So here we will remove the processes. If the other process is getting into the CPU, we'll make the Gantt chart. So here always we will assume that 0 as the arrival time. So at 0 we are starting. So at 0, is there any processor is coming? Yes, the P4 is getting. So in all the previous problems, we are writing directly the burst time of the process because they are non-preemption methods. That means there is no any interrupt, that is there is no any other process coming in between this process is running, so we are writing directly the burst times. But here the scenario is, while one process is getting run in the preemption method, the main agenda is interrupt is coming. So while one process is running, there is the interruption. That means there is another process getting into the CPU to run the process. So here we will take only the 1 unit of time of each and every process. So listen carefully. So we took P4 as the arrival time of it is 0, and it completed its 1 unit of time in the CPU. That means, so it have done 1 unit of time, so its burst time becomes 5. I hope you are understanding. So please listen carefully. We'll do multiple problems. Okay, at 1. At 1, is there any process is coming? Yes, at 1, P2 is coming and P4 is also there. P4 is just waiting because interruption is occurred. That is the main thing of shortest remaining time first. So P2 is there and P4 is there. In P2 and in P4, so what is the thing? We'll compare again the burst times. So you remember the scenario of shortest job first, which is equal somewhat have the similarities with this with SRTF. So we have two burst times as equal. Then what we'll see? We'll see the arrival times. In arrival times, which has the lowest arrival time? P4 has the lowest arrival time. So again, we will place P4 here and it completed its another 1 unit of them, that is 1 plus 1, 2, and here we'll cancel it to 4. I hope you are understanding the logic that is going here. So at 2, what are the things, what are the processes we have? So P2 is there, P4 is there, and at 2 we can see again P1 and P5 also. So P2, P4, P1, P5. Okay. Now again we'll compare the burst times because we have four processes to whom we'll take into the CPU. So here we'll have the burst times of P1 is low and P1, yeah, only P1 is there because P2, P4 and P5 burst times are more than P1. So for P1, again we'll write. So here the only burst time for P1 is 1. So 2 plus 1 is 3 and P1 is completed. So P1 is completed. Now at 3, what are the problems, what are the processes coming? P2 is coming, P4 is coming, P5 is coming because P3's arrival time is 4, so we'll not include it in the ready queue. So P2 and P4 and P5, so which process we'll select? P2, P4 and P5. So similarly, which have the lower burst time? So P5 is getting selected. So for P5 we will take 1 unit of time. So that is the main thing we are doing in the shortest remaining time. Why we are doing? Because there is the interruption is getting occurred. If one process is going on, there is another process which have the more priority than the current running process. So here it will do only its 1 unit of time and it gets waited there, and another process comes into the CPU, it gets run, and if again is there any other process coming, then these two will be waited and we'll make that process to run. So this is the main thing, but we'll see here the lower burst times. If they have the same burst times, again we'll go to the arrival time. So similar to the shortest job first, but here we are running only 1 unit of time. So P5 4. That means what are remaining? P2, P4, P5, and here in the ready queue P3 is also coming. So P5 is completed. Okay. Next we'll see P2, P4, P3, which have the lower burst time P1. So now P3, sorry, P3. So 1 unit of time, 4 plus 1 is 5, right? So 5. So here for P3, it is done. P1 and P3 processes are completed. Now we have P2, P4 and P5. Once in shortest remaining time first, very important point to be remembered is once the all processes comes into the queue, we follow SJF from here. Okay, we'll follow SJF, which is very important. So please remember, we'll follow STF from here. That means we'll not write 1 unit of time here again. So we'll follow STF. So here you can see P2, P4 and P5 are there. P2, P4 and P5, which has the lower burst time P5. So P5 is written 5 plus 2 is 7. And next is P4, 7 plus 4 is 11. And next is P2, that is 11 plus 5 is 16. So if we add all the original burst times, original burst times, original burst times. This is also very important. So while calculating the completion time or the total run time, don't calculate these cancellations. You have to calculate the original burst times. Okay, with respect to original burst times only, we'll calculate. So if we do the sum of all the burst times, so you will get answer as 16. 6 plus 3, 9, 10, 16. So completion time is nothing but for P1, the completion. So we'll write the last completion time 3. For P2, it is 16. For P3, it is 5. And for P4, don't write this. The total completion time of how many times the process came. So P4 finally here it was ended. So its first time is 11 and for P5 it is here also there and here we'll take this one. P5 is 7. So turnaround time, again I'm writing the formulas. Turnaround time is equals to completion time minus arrival time, and waiting time is equals to turnaround time minus burst time. Okay. Hmm. So turnaround time, completion time 1, 15, 1, 11, 7 minus 2 is 5. And waiting time, turnaround time minus burst time 0, 10, 0, 11, and 5 minus 2 is 3. Okay. Oh, 5 minus 3 is 2. Okay. Waiting time, turnaround time minus burst time. 11 minus 6 is 5. Sorry. Okay. So now you can calculate the average, average turnaround time and average waiting time. Okay. So average turnaround time means 1 plus 15 plus 1 plus 11 plus 5 divided by 5, and 0 plus 10 plus 0 plus 5 plus 2 divided by 5. So let's see the another problem, and later I will give you another homework problem. Then you will understand this preemption method of the SRTF. Yes, we assume that it is starting from 0. Is there any process is coming at the arrival time 0? Yes. So P1 is getting. So we'll take 1 unit of time from it because it is SRTF. They will mention in the question. So we'll take it as 7. Next, at 1, what process is coming? So P2 is coming at 1. So we'll write here P2 and its take as in 1 unit of time. We'll write it as 3. So at 2, is there any process coming up? Yes. So we are still remaining with P1 and P2 and again P3. So at P3. So the burst time is less for P3 only among P1, P2. In the before question or in the before step also, P2 has the lesser burst time than P1. So I have written here P2. Okay, please make sure of understanding that. So P3, now I'm writing P3 here. So it will take 1 unit of time and here you will have 1. At 3, what are the arrival times coming? P4 is also coming. So we have in the processors in the ready queue P1, P2, P3 and P4. Okay, in these the lowest burst time for P3 it is there, for P4 also there. Same burst time is there. I have already told if there are same burst times for the things, then we have to take the arrival times. Okay, so let's see the arrival times. Arrival time for P3, for P1, P2, P3, P4 low. We selected P3, P4 as they have the lower burst times. In this, we'll see the arrival times. So P3 has the lower arrival time. So again, we'll make P3 into the queue and we'll make here 4. So P3 completed because 1 unit of time is done here. So P3 is completed. And what at 4, is there any process coming through? Yes. So P1, P2, P4 and P5. Okay. So in these 4, again, we'll see the arrival times. So simply here we'll write the P4 because it have the lower burst time. So P4. So 1 unit of time is getting completed. So we'll write 5 and here P4 is also done. At P5, is there any process coming into the ready queue? Yes. So what are the remaining P1, P2, P5 and P6 is also coming. So I already told you in SRTF, the main thing is once the all the processes are entered into the ready queue, like P1 to P6, then we follow from here SJF, that is shortest job first. That means we'll see now P2, P1, P2, P5, P6. P1, P2, P5, P6, which have the lower burst time. P6 have the lower burst time. So P6, so P6 burst time is 2, 5 plus 2 is 7. 5 plus 2 is 7. And next, so P6 is completed. P1, P2 and P5. So P1, P2, P5, P2 have again, P5 have again same burst times. So we'll see their arrival times. P2 has the first arrival time. So we'll write P2 here after P6. That is 7 plus 3 is 10. And P2 is also completed. And in P1 and P5, we'll select P5. That is 10 plus 3 is 13. Yeah, is it right? Yes. Next P1. We have 13 plus 7, that is 20. So if you add all these burst times or the original burst times, you will get it as 20. Now we will write the completion time, turnaround time and the waiting time. Okay, I hope you understand the problem of SRTF. So 20 and 10, 4, 5, 13 and 7. 29, 2, 2, 9, 2. And waiting time is 12, 5, 0, 1, 6, 0. Okay. Next. So let's go to the homework problem and comment in the comment section the Gantt chart. Then we can clearly understand is it correct or wrong and find the average waiting time and average turnaround time. Thank you. I hope you have understood this video.